Hello and Assalamualaikum. I am Muhammad El Haikal bin Asbolo. Today we're going to talk about experiment number 5, measurement of jet forces. So, for this week is actually I'm the leader, and these are my group members Shafiq, Afan, and Al Hafiz. Next slide, please. So first I'm going to explain about the report summary. So basically, the objective of the experiment is to compare the force that was exerted by a fluid jet hitting upon a flat plate or a hemispherical surface with the values that was obtained by the theory. So we need to compare those values. So for this particular experiment, there were actually 11 apparatus used. So the first one are actually the weight position, a deflector, the nozzle from the picture, the tank, the water supply, the lever mechanism, and also the main switch box, the flow control valve, the water drain, the volumetric measuring tank, and also the sliding valve. So next slide. So I'm going to explain about the theory now. So when a stream jet of fluid hits a flat plate or something that has a hemispherical surface, it generates a force due to the change of momentum of fluid based on Newton's second law of motion. For instance, when a high velocity water from the jet nozzle with a certain diameter strikes a plate or a hemisphere surface, the rate of change of momentum produced at that time or at that moment with its magnitude is actually the same with the force exerted on the surface aimed to support the water jet. The force generated by a jet of water when it strikes depends on the shape of the surface, which is either flat plate or a hemispherical. So next slide. So as we can see from figure 1 and figure 2, we can see that a jet of fluid is issued from a nozzle with a respective diameter of d, moving upwards with a certain velocity, which is v1, and hitting a flat plate and hemispherical surfaces. The jet is then deflected by the surface of flat plate or hemispherical through an angle theta and leaves the surface with a velocity level v2. So figure 1 is for the flat plate and figure 2 is for hemispherical surface. So next slide. So these are the formulas that we are going to use in our calculation for raw data analysis. So the theoretical force generated when the jet of fluid hits a flat plate is F is equals to PA velocity 1 squared minus P area V2 squared cos theta, where theta is 90 degree. As we can see from the previous slide, actually it's at 90 degree, and that's the equation 1. So that means that when V2 cos 90, it means equals to V1 is equals to 0. So F is equals to P. We can summarize this thing into F equals to P AV1 squared, which is actually equation number 2. So next would be the hemispherical surface, which is in theory it's the same as before, but the angle is actually 180 since it comes back to the degree from where it came from at first. So that means that V2 cos 180 is actually meaning is negative V1. So V2 is actually equals to negative V1. So from there we can actually take equation number 4, which is F equals to 2 PA V1 squared, which is equation number 4. So next slide. So I'm going to pass to Shafiq to explain about this part.
So I will explain the experimental procedure. Number 1, the tested deflector, or known as flat plate, was assembled. Number 2, the pointer was set to 0 by adjusting the screw at lever mechanism, and when doing so, it was made sure that there is no any weight on the lever mechanism. Number 3, the main switch and the pump were switched on. Number 4, the flow control valve was slowly opened and the desired weight was put on the lever mechanism. Then the valve was adjusted again until the pointer at lever mechanism was at 0 notch. Number 5. The sliding valve was closed and the flow rate of water Q was determined by recording the time T required to fill up 2 liters of water in a volumetric measuring tank. Number 6. The sliding valve then was opened. Then step number 4 and 5 were repeated by increasing the desired weight on the lever mechanism until the flow control valve is at maximum opening. Next, the main switch and the pump was turned off. The sliding valve was opened and the flow control valve was closed. Lastly, the weight on the lever mechanism was removed and the deflector was changed from flat plate to a hemispherical surface. Step number 2 until 7 were repeated. Next slide. I will pass to the next presenter.
So for the raw data analysis, there are 4 aspects which we need to calculate, which is V, theoretical force, and percentage of the measured force, volume of water collected, and the time were given by the lecturer in the e-learning.
Okay.
Plate, the measured force is 4, 3.6, 3.2, 2.8, 2.0, 0.2, 0.8, and 0.4 Newton. So the QX is volume of water collected is divided by time. For the V, calculate the value by using the formula from Q is equal to AV.
Q equals
Then
AV.
calculate the value for V. Theoretical force, we just like Haikal said before, for the which is of flat plate rho AV squared, and for hemispherical plate 2 rho AV. This is the data we got after calculate the value. So for the discussion, the first one is plot a graph of log F measured versus log V for both the flat plate and hemispherical
surface.
So this is the data. We just put on the calculator log V measured and log V. So this is the graph. The upper one is for hemispherical plate, and the lower one is the flat plate. So the second one for discussion, estimate the slope of the graph for both the flat plate and the theoretical value as shown in equation 2 and equation 4 respectively. Comment on the difference. So for the hemispherical plate, we know that the formula is for 2 rho area V squared. So we can calculate the value. So for the flat plate, theoretical force is rho AV squared. The difference between these two is only 2 hemispherical plate. We can calculate the gradient by using the formula y2 minus y1 over x2 minus x1. For the value gradient for hemispherical plate, we got that 1.813. For the flat plate is 1.687. There is slightly different value between slope, theoretical, and graph. where the theoretical value that we got for flat plate and hemispherical plate are 1.813 and 1.687 respectively.
Okay.
This is due to the different angle of water ejected that cause the differences in value.
Oh.
Next one. Estimate the y-intercept ratio of hemispherical surface to flat plate and compare with the theoretical ratio as deduced from equation 2 and equation 4. So for the we use the y equals to mx plus c. So we got the value for c is negative 0.9926 and for the hemispherical plate we got the value for c is negative 0.5363. So for the intercept ratio we just divide hemispherical plate over flat plate. We got 0.5403. For the theoretical value, we divide negative 0.6009 1.105 to 0.4538. Between theoretical value and measured value is only 0.003 plus minus. There will be minor and major losses of the water when going through the pipe and striking the plate. To the next presenter.
Okay, we'll continue for discussion C. For discussion C is compare the force exerted on the hemispherical surface with the one on the flat plate, which one is greater, and state the reason. So the force exerted to the hemispherical plate is greater than force exerted on the flat plate. It occurred due to the different action between plates, where the greater the angle will result the greater value of momentum. So this is proven by theoretical force equation I highlighted just now. For second Roman question is compare the percentage of relative error for both the flat plate and hemispherical surface at velocity, and comment on the analysis and explain the reason. So for flat plate, the percentage average goes to 8.1730%, and for hemispherical equals to 4.5670%. This is calculated by of average FM, which is force measured minus average theoretical average theoretical. So we got this percent. So from the data obtained, we can compute the percentage of relative error of the plate is higher than the relative error for hemispherical surface, due to a constant strike of fluid jet, and affected the angle shape of both the plate and surface. Next slide. Also, for the question of number 3, briefly, the question asks for discuss the factor contributing to the error or inaccuracy in experimental data, and the possible recommendation to improve the existing result. So inaccuracies made during the experiment cause some value of percentage error, very large. One of it is the percent of leakage at the tank that affect losses of water collected. So besides that, periodic error might occur due to error in the position of ice during taking the data. Next, random error occurred when light in motion of the spring result in unpredictable fluctuation of values. The elasticity of spring will directly affect force exerted and volumetric flow rate of water. And lastly is environmental factor, which cause the water surface to ripple due to air movement, things affected the result. Next, for the overcome or the precaution step, we should focus on the few. We should focus for certain. It's really important to check the condition of our apparatus. And next, we must make sure our eyes to the reading scale, like fresh data collected by repeating the experiment will be more accurate to reduce accuracy. So to avoid random error, we need to prevent shaking to the spring coil by slowly adding the load weight as reading must be taken in steady condition. Furthermore, turn off the fan to prevent environmental factors. In discussion is the two application of jet impact in industry. So in industrial sector, jet impact act as cutting machine that can slice through anything with high pressure stream of water. Besides that, Pelton wheel can be rotated by using jet impact to generate electricity. So electrical energy will produce when moment created by tangential force reach maximum value. And last part is, so what we can conclude in this experiment. The experiment was done successful. So the objective of this experiment is to compare the force exerted by the fluid jet upon a flat surface has been achieved. So from the equation itself, show that force acting on hemispherical surface is greater than the force on plate. So this happened due to the different angle of deflection of water jet. So some errors occurred which resulted in the inconsistent of the data. Also have given just now to improve the experiment. I think our group. Thank you.